In this video, we'll take a look at the holy grail of wireless attacks, the man-in-the-middle attack. It is considered to be the holy grail of attacks because the attacker who performs this will be able to capture, analyze, and even modify the data sent by the victim. Let's see how this attack works. Assuming that we have a legitimate client, the victim in our case, that is connected to the internet, the server in our scenario. Initially, the victim is directly connected to the internet. The connection type could be either a wired or wireless one, as we will see in our demonstration. Then there's the attacker, a hacker who breaks the connection between the victim and the server and reroutes the connection through his computer. We will play the attacker role in this scenario. In the wireless connection case, the attacker will simply create a fake access point having the same SSID as the legitimate one, the one that the victim is using to connect to internet. The connection can easily be interrupted by sending deauthentication packets to the victim in the behalf of the legitimate access point. After that, assuming that the fake access point has a powerful signal than the original one, the victim will use this fake access point to connect. Now that we have the victim connected to our fake access point, we need to reroute the traffic that is coming from the victim's machine through our machine and reaching the internet so the victim will not notice anything unusual. Assuming that we have an internet connection from our machine, we will need to bridge the internet connection, ADH0 in our case, with our fake access point, so the traffic coming from the victim's machine can reach the desired destination. We will, however, be able to capture all this traffic and eventually alter it. Let's see how this works in practice. In this video, I will use the Kali Linux machine from VirtualBox, as bridging the Ethernet with the wireless access point connection will disconnect me if I was about to use the secure shell protocol to connect to the Raspberry Pi machine. The VirtualBox machine is also much faster than the Raspberry Pi, which will speed up the demonstration, but that doesn't mean that you can't use a Raspberry Pi for this scenario. One thing that I want to specify before getting started is that for this lesson we will need to change the network adapter mode for our Kali Linux machine running in VirtualBox. So I have opened VirtualBox and selected the Kali Linux appliance. Then we go to settings and from here we choose network. For the adapter 1, make sure that NAT or network address translation is selected as networking mode. The demonstration will work properly if this setting is made. We are then ready to start the Kali Linux machine, and we can do that by pressing the Start button. Let me switch to the full screen mode by pressing Ctrl+F, and as soon as the Kali Linux has finished booting, we will be able to log in using our username and password. Before being able to use the USB wireless card in the virtual environment, we will need to enable it by making it available to our virtual machine. For that, we choose the Device menu, navigate to USB devices, and from here we select the Atheros USB 2.0 WLAN wireless adapter. If you're using another wireless adapter, you will need to select that specific device in order to become available in the Guest machine. Next, let's open a new terminal window and let's start by checking the availability of a wireless adapter. For that, we issue the lsusb command, which will display the USB devices connected to our machine. We can see that our wireless adapter has been recognized. Great! Let's put it into monitor mode by issuing the rmon-ng start WLAN 0 command. And as we can see, monitor mode has been successfully enabled on the Mon0 interface. Now let's create our fake access point. For simplicity, we will create an open access point which uses no encryption. Also, I will assume that you already know by now how to use the areplay command to send deauthentication packets to the client in order to break its connection with the real access point and connect with yours. So, back to our mission, I will use the airbase-ng command to create a fake access point. The parameters that I'm going to use are --ESSID to specify the SSID of our access point, and I'll use MITM in this case for man in the middle, and the channel that we want the access point to work on, which will be 6. And oops, I forgot to specify the interface that we are going to use, and this will be Mon0, our monitoring interface. Great, the access point has been created, and we can see that a new interface has been created also, called AT0 or the tap interface. This interface will receive a copy of every wireless network packet. So far so good. Now, in this example, the interface that connects our machine to the internet is ATH0, so we will need to bridge this interface with the one just created, AT0. There are a couple of ways to achieve this in Kali Linux, but one that I am choosing in this lesson for simplicity is to use a utility called Bridge Control. This utility is part of the Bridge Utils suite that might not be available by default in your Kali Linux installation, so we will need to install it, and we can do that by typing apt-get, the Kali Linux package manager, followed by the install and the name of the package, which in our case is bridge-utils. And we end the line with the -y option, which runs the apt-get utility in non-interactive mode. Now in my case the bridge-utils package is already installed because I've installed it earlier, but this command should install it in your Kali Linux machine in case it's not present. Before going ahead and bridging these two interfaces, let's type ifconfig and take a look at the available network interfaces. We have WLAN 0, Mon 0, the loopback interface, and the ATH0, but no AT0. This means that the interface is down or disabled, and we will need to bring it up or enable it by using the ifconfig AT0 up command. Let's use the ifconfig command one more time, and this time we can see that the interface is up and running. It's time to bridge these two interfaces, AT0 and ATH0. The command that we are going to use is part of the suite that we just installed earlier and is bridge control. So I will type brctl, and we need to start by creating the actual bridge. So I will type addbr, which stands for add bridge, and then the name of the bridge. Let's call it MITM for the man in the middle. Now that the bridge has been created, we need to add two interfaces to it. To check the status of a bridge at any time, you can use the brctl show command. We can see that the bridge is available, but no interfaces are assigned to it. Let's add our interfaces by using the brctl add if, which stands for add interface, followed by our bridge name MITM and the interface that we want to add, let's say ATH0. Then we need to add a second interface, so we type again brctl add if MITM, the name of our bridge, and this time the AT0 interface. Great! Now that the bridge has been created, we need to reset both of these interfaces by using the ifconfig ATH0 0.0.0.0 and up command, which resets the interface and makes sure that is enabled. We'll do the same for the AT0 interface. And finally, let's bring our bridge interface up by typing ifconfig MITM up. And as an optional step, let's try to obtain an IP address for this interface from the DHCP server by issuing the dhclient MITM command. Great, the stage is set. Now it's time to invite our guest, the victim. But before doing that, let me open Wireshark, so we will be able to capture and see the traffic that goes through our network. The interface that we will use to sniff the traffic on is AT0, the tap interface. And I'll press the start button to start capturing the traffic. In the meantime, let me go to my MacBook Pro laptop and use it as the victim in this scenario. It doesn't really matter what device or computer is used as the victim, but the MacBook Pro allows me to better capture the screen for demonstrations purposes. So here I am on my Mac, and I will manually connect to the fake access point which has the SSID of MITM. In real scenarios, the attacker will send the authentication packets to the victim in the behalf of the legitimate access point in order to disconnect it and connect it to his own fake access point. So here is the MITM wireless network, which is using no security and no encryption, as we can see. Let me connect to it and see what happens. Okay, great. So now I'm connected to the network, and let me minimize this window and use the Chrome browser to navigate to, let's say, google.com. As soon as I press enter in the Google Chrome, we can see some activity in Wireshark. There are some ARP, DNS, DHCP requests and so on, meaning that we are on the right path. Now, loading the page on the Chrome browser takes more time than usual, but other than that, there are no signs that something is wrong. I mean, the Google page looks real and is real because the page has been accessed from the Google servers. The only problem is that the connection to the Google servers was done through the fake access point. Okay, maybe Google was not a great example because the browser is using the same page as the home page, so let me navigate to yahoo.com instead. As we can see, again a lot of activity in Wireshark, and again the loading is taking more time than usual, but the page has been loaded successfully. And the final test, let me access my router's admin interface located at 192.168.1.1. Same as before, a lot of activity in Wireshark and the page loads slower than usual. Now let's try accessing the status tab of the admin interface, and we are asked for a username and a password. Okay, let's cancel this for a moment, and we can see an unauthorized page being displayed. Let me quick stop the capture in Wireshark and start it again so we will have less data to go through, and let me again try to access the status page of the router. And this time I will provide the credentials, which if I remember well are root for the username and admin for the password. These are the default credentials, but don't be lazy like me and change the username and password as soon as you set up your router. In my case, this router is not directly connected to the internet. I'm only using it for this course, so I didn't bother at changing the username and password. So root and admin, remember that. And looks like we are successfully connected and able to see the status page. Our victim's job has completed. Now let's see what we can find in Wireshark. First, let me stop the package capturing and let's filter the traffic to display only the HTTP requests. I mean, we are only interested in the HTTP requests between our victim and the router. Now we have much less traffic to analyze. Great! And by going through this, we can see the unauthorized page requested that we were received when we cancelled the authentication process, and a few lines later we can see the GET request for the status_router ASP page. This should be interesting. Let's take a closer look. I'm going to extend this details window and let's take a look at the Hypertext Transfer Protocol packet, which surprisingly, or not, contains a field called authorization. Let me open this and voila! The credentials that we provided as root and admin can be found here. Now, how is this possible and why are these here in plain text? Well, that's because we, as the attacker, created a fake access point and tricked a victim to connect to it and then captured all the traffic the victim was using to access the internet. But why are those credentials in plain text? Well, that's because the admin interface of the router does not use encrypted connections like SSL. If the interface was using SSL or HTTPS requests, we will not be able to see the credentials in plain text. So in this scenario, we will only be able to see the credentials and other type of information from the websites that are not using SSL or HTTPS requests. However, it is still possible to see the details for some websites that are using HTTPS, as we will see in a later video. What we accomplished in this lesson can be considered the highest rank of wireless hacking, because we were able to intercept the communication between a legitimate client, the victim in our case, and the internet by rerouting his traffic through our fake access point, and we acted as a man in the middle between these two. Thanks for watching.